In this video, we are going to talk about parametric equations of a circle. Parametric equations of a circle. So now let's begin. When we say parametric equations of a circle, what we mean is that it's an equation that gives the coordinate of a point in only one variable. It gives the coordinate of a point in only one variable. So let's say these are the coordinates. Let's say that these are the coordinates. Let's say these are the coordinates, A and then theta. So A here is the variable, but theta is constant. Okay, theta is the angle. Theta is the angle. Though the angle may change, but then we assume that theta is constant here, so that always we can know that the only variable is one, whereas the other ones that we have studied so far, the coordinate were defined by two variables such as AB or negative j and negative f. So that's the difference. The difference between a parametric equation and then any ordinary equation is that when it comes to the coordinate, the other equations will give the coordinate of a point in terms of two variables, whereas parametric equations will give the coordinate of a point in terms of only one variable. So that's the main difference. So here, let's consider the diagram. So this diagram describes a circle. Now, there is a point R, bigger R on the circumference, and then also it has center C. It has center C. I said earlier on, or in our earlier lessons, that to be able to describe or to write the equation of a circle successfully, you need to know the center of the coordinate of the center of that circle and then the radius as well. So here you can see that small r is the radius, but before you can determine small r, you have to use the length, that's cr. You have to use cr, line CR, to be able, so you can use the length formula. And to be able to use the length formula successfully, you have to know the coordinates of both points, that's R, the coordinates of R, and then the coordinates of C. So here we know the coordinate of C to be A, comma B. Those are the coordinates of C. Then how do we get the coordinate of R? Now, to get the coordinate of R, first let's try and then resolve R into each component vectors, because it is inclined. This is a vector because it has position. It is a position vector. So what happens here is that we can resolve Cn. So Cn, as we did in our previous lessons, we know that cos of any angle is associated with the x-axis, whereas sine of any angle is also associated with the y-axis. So to get Cn, which is along the x-axis, we take cos. So cos of theta, so we can say that cos theta, that's the angle under consideration, is equal to Cn all over r. Therefore, our Cn will be equal to r cos of theta. That Cn will be equal to Cn. So that's our Cn. And the same thing applies to that's our this point, this perpendicular axis, which is the y-axis, will also be, so sine of the angle under consideration will be equal to rn over rn over rn over rn over r. Small r, that's the length or the position vector. So we have r sine of theta. So that's it. So we have Rn is equal to r small r sine of theta. So now that we know that, now we know the vertical and then the horizontal component of r. So how do we get the coordinates of r? Now, to get the coordinate of r, it becomes the coordinate of r along the x-axis. So let's say the coordinate of r are, we have x. Every point is described by two coordinates, the x coordinate and then the y coordinate. Though at higher levels we have points that are described by three coordinates, that's the x coordinate, the y coordinate, and then the z coordinate. But our level, we are only considering two coordinates, that's the x and then the y coordinate. So how do we get the value for this coordinate of r? Because we can only do that after we've gotten the value for, or we've gotten the coordinates for r. That's when we can find for the position vector using the length formula. So here all we do is that we have to know that x will be equal to where x starts from. So x does not start from the line segment, this one. It does not start from the origin. It starts from a point A. So A plus of r cos theta. Yes, that's our x. And then our r will also, and then our y will also, that's the y coordinate, will also be, where does it start from? It doesn't start from the origin. It starts from a point, and that point, or it starts from a distance, and that distance is b. So b, where it starts from, plus of the y axis, which is r sine of theta. So these are the coordinates of r. So you realize that here the coordinates are expressed in terms of only one variable. So if you look at the coordinate x, it is expressed in terms of only a variable. Now this r cos of theta is constant. And then also this b is a variable, and this r cos of theta is also constant. It means that it's the same, because it's the same length. Okay, it's the same length, because the position vector is constant, and then the angle also is constant. Here the angle is not changing, and then the position vector is not changing. But what we have to look for is a, that's the coordinate of the center, and these are where it starts from. It does not start from the origin, so we have to include that. So basically here, after we have this, we can try and then derive the equation of a circle from this. So we can see that now we have our x. So x is equal to a plus cos of theta. So we can see that r cos of theta. So we can see that a minus x minus a is equal to, all over r is equal to cos of theta, because we moved a to the other side of the equation, so it became a minus this, and then we divided by r, both sides by r, so we got this. The same thing also applies to sine. We can get y minus, so we know that y is equal to b plus of r sine theta. So we have our y minus b is equal to sine. So here to you divide, and then you have sine of what? Theta. So please, let's note this. We want to derive the equation of a circle from this. Now from here, what we can do is that we know from our trig ratio that, from trig identities, that when you have cos square theta plus sine, that's one of the trig identities or trig ratio identities. You have sine squared will be equal to 1. So here I can say that then my cos, I know my cos to be into bracket x minus a all over r. I can square it, then plus of my sine also, which is also y minus b all over all over my r all over r squared is equal to 1. So in this case, I want to get rid of the fraction. So I multiply through by r. If I multiply through by r, I get the final result to be x minus a into bracket, then squared, then plus of into bracket y minus b also squared, all is equal to my r my r is also what? R squared, because r is in the bracket, so it's been affected by according to indices. So this square is affecting the y minus b and then also the r squared. So we have been able to obtain the equation we have been able to use the parametric equation to determine the equation of a circle. So this is the standard equation of a circle as we stated earlier. So x minus a squared plus into bracket y minus b squared is equal to r squared. So this is how we can use the parametric equations to derive the equation of a circle. Thank you very much, and let's meet in the next video. Bye.